Still, okay.
Near phone locks.
Good morning to all. Today we are going to have a discussion on the topic process design based philosophies. So as you all know, it is a very vast, deeply important topic. I'm not very sure if I can cover all the aspects in this short time. So I'll be keeping it very brief. And it's going to be only an overview of the whole philosophy. Okay. So firstly, what are philosophies? Anyone know what are philosophies and why do we require philosophies? We'll have an interactive session. So you will be seeing any questions like why, what, which, how. So in between we'll not break or anything, but when I ask some questions, somebody can answer. Again, I would ask Alan will be joining only for debate. So, percolating. Okay, we'll continue. So, at last, we'll have a small break. If you have any doubts, we can clear that time. So, we'll see what are philosophies. Example. Okay, something is not right about this image. See, there is a problem. I have drawn this in some software, not AutoCAD, some random app. Not supposed to be like this, right? Let's see. You okay now?
Yes.
Seems to be fine, or is it?
No.
Here, inlet and outlet directions. Vertical blind in the line to flare. Actually, it should be near to the vessel, right? And similarly, the open drain line. The vertical blind it needs to be downstream, right? Then only if you are sailing for a maintenance, you can isolate the vessel, right? So what happened? There is an instruction here. Can you see? There is an instruction, right? This arrow doesn't seem to be right, right? Is it okay now? Yes. Absolutely. Now it makes sense, right? So when we saw that instruction and we followed it, it is okay. I hope you all got my point. So what are philosophies? Philosophies are nothing but general guideline defines some criteria, methodology, limitations for a process design. It will be used for designing various deliverables, process deliverables like PNID, PFD, treatment specification, etc. So that's okay. Why do we require a philosophy? It is to ensure that throughout the project. Okay, so we have some aspects like safety, reliability, efficiency, flexibility, economically and economic and environmental impact. All to be taken into consideration. Also the maintenance aspect. So these aspects needs to be taken into consideration while we are designing. Also, for a project, for a specific project, the philosophies, it should be continued throughout the project. So these aspects should be continued throughout the project. That's why we require philosophies. Okay. Now, That's okay. How we are going to implement this aspect into the philosophies? Let's see. There are few aspects. First one is safety. So safety first. We need to follow proper safety guidelines, complying to the industrial standards to avoid or minimize accidents and protect the personnel and like assets, environmental impacts, everything. Okay, so next one is reliability. So when we are designing a plan, this is another aspect we need to check. Like the plan should be designed to run without any downtime. That is, should be redundant. So next one is efficiency. As a process engineer, one ideology you all should keep in mind by all means is that we should efficiently utilize resources, whether it be water, energy, or improvement in overall efficiency. We should keep that in mind. Next one is flexibility. Plan should be flexible enough to adapt to any conditions, like summer, winter, weather conditions, or future expansions. Okay, that is also another factor. Next one is economics. This is very important aspect. You have heard about capex and FX, right? Capital investment, capital expenditure, and operating expense. So from the starting stage of the project, this feasibility of the whole project itself depends on this aspect. On the potential revenue from the plan. If you are designing plan, there should be potential revenue from it, and it needs to be recovered. The cost needs to be recovered, and we need to make a profit. So capex and opex will be closely monitored. If we are trying to like reduce the operating cost, somehow there will be an impact on the operating cost, and vice versa. So that is another aspect. Then there is environmental impact as well. Okay, so environmental impact. We should reduce all the emissions, wastage, and minimum consumption of the resources. We should adopt alternative technologies if required. Next one is maintenance. So selection of equipments shall be done considering the maintenance aspects, like availability of spares, then like providing spares to reduce downtime of this. So these are the aspects. Now we'll see which are all the philosophies. Can someone list out few of them?
Expression of philosophy.
Okay.
Safeguarding philosophy. Relief and slow.
Okay.
Control philosophy. Isolation. Brains like
Okay, we'll see one by one. Safeguarding, relief and program, acceleration philosophy is there, sparing philosophy is there, operation control philosophy is there, and then. So in this discussion, we are not going to go through each of them because we won't have any time. So I've selected like isolation philosophy, sparing philosophy, and bend and play for this session. So if anyone is interested, we can take the others as separate topics. Okay. So first we'll go through isolation philosophy. Okay. Why do we require isolation?
protect.
As it's to isolate an equipment or a unit for maintenance, not shutdown. Isolation is required. Or maybe there is a changeover of an equipment to the other. Isolation is required. So mainly there are two types: walled isolation and positive isolation. Okay, we'll see what all of those. First, we'll see walled isolation. So walled isolations are used when there is a non-entry or low risk operation. These are of two types, proven and non-proven. Some types of word isolations are mentioned here. Single block and B, double block and B. You all come across this, right? In PNIDs. So we will see each and every one in detail. First one, single block. This is the lowest ranking of all these isolations. It is used for low pressure and non-hazard and infrequent. If the operation is very infrequent for the field uses. This is non-reliable actually. It also cannot confirm any possible leakage. Now, single block and bleed. It is also similar to single block, but with a bleed rod. So, why do we require a bleed rod?
Increase the ball forces.
Because so we'll come to know if there is any leakage. So bleed rod is provided in downstream of the pressure source. So bleed, as we said, bleed is to provide the integrity of isolation. If the proper isolation is there or not, there is any passing, we can come to know through the bleed. So in case of leakage is found, we can take additional measures. Further topping which can be done or required cut down is to be done. Then there is double block. So for the single block, there is an additional word provided to like limit the further passing. It can be used for higher pressure applications. This also is not maybe considered as a reliable option because it cannot confirm this possible leakage. If there is a passing to the first one and further passing to the second one, we can come to know. So there is this double block end. Here we can confirm the leakage, integrity of the isolation to the block, bleed. Okay, you all know what is PDP, right? Now we'll see like where all it will be used, the applications. Here is a like typical example of taken from some client. Anyway, it will vary from project to project based on the client requirements. Selection of quantization will be based on toxicity, porosity, granularity, temperature, pressure rating also. So you can see based on pressure rating. Someone hello. Unmutable. Okay. Okay, so based on the pressure rating, you can see the stable and also with the toxicity or type of fluid handle, we can have the selection criteria. It will vary. This is a typical example. This will vary from project to project. Okay, generally for high temperature and like high corrosive fluids, we use EV. Next type of isolation is positive isolation. Okay, this positive isolation will be used when there is a man entry involved. Also, if, like proper isolation for containment of the fluid is required. It will be used for long maintenance requirements, and sometimes it will be used in combination with the wand isolation also. So we'll see the type of positive isolations are removable spools, spectacle blinds, spacer replaced with the blinds with the flanges. See one by one, blind flange. What is blind flange? So be kept at the end of the pipe bar. Now, spectacle blind. That also you all know. Like when we require a close position, we'll like the spade area of the spectacle blind will be reversed. And if we require in open condition, the spacer will be it will be reversed. So, spade and spacer is that this like the basic version of this. Uh, there are some criteria of usage for spectacle blind as well as paid and space. That also like varies from uh, client to client requirements based on pressure rating. Like here is an example, like for 150 plus rating, up to 12 inch we can use spectacle blind. Further than that, we'll use paid and space. Okay. So the typical example it varies. Now we'll see some isolations. Positive isolations are like as we saw, positive isolations are spectacle lines, paid and spacer, mobile scope. Also, it can be used in combination with uh, like non isolations, like SPB plus positive isolation or DBB plus positive. Okay. Also, the proven and proved isolation. This you or know, like if there is a bleed, we can call that as proven. And without a bleed, it is not proven. Okay. Now, there is something else we need to cover, like securing wall positions. You have all seen like lock open, lock close walls, right? What are these? For example, there is a pump changer or ESP is to be taken for maintenance. We have seen this. We'll provide lock open, lock close. So what are these? The valves can be locked or opened to prevent inadvertent operation. If there is a by mistake some operator operates it like incorrectly, it will cause a high risk. Then this valve securing position will. So there will be some dedicated procedures also for some securing water. See one by one. One is lockout type of that is lock open or lock close. This will be like simple locking arrangements with key or tag. It's then car seal open and car seal close system. It will be like instead of lock, it will be metal or plastic cable. It will be fixed on the wall to so that someone by mistake don't open or close it. Then interlocks, ILO and ILC. These are like locking arrangement itself, but the locks will be trapped inside the like wall itself. So only one wall will be at a time open or close. So we'll see an example. Here we can see the ILO and ILC operation. For a normal wall, this interlock will be fitted. I think it is for PSV, operant also. So this interlock will be a unique key which will be stored somewhere. Only the correct key can open or close the wall. Mechanical. You're able to see it probably.
ഒരു പാനൽ സംഭവത്തുണ്ടല്ലോ ഓപ്പറേറ്റ് ചെയ്ത്
So as you see, when opening a wall, first we need to isolate a wall. Then only we can get the other key inside from the wall which we closed. Then only we can open the other one. After the operation, it will be stored in the key set.
ചേട്ടാ അതൊന്നുകൂടെ എക്സ്പ്ലെയിൻ ചെയ്യാം കീന്റെ.
Okay. Yeah, on a normal wall, this interlock will be set. Okay, this it will be based on both the walls, whichever needs to be opened and closed. And there will be only one key which we can store in the lock set. It will be from one wall. Okay. So any other type of walls will not enter the other wall. Okay. So it will be stored safely. Once there is a requirement to say interchange the PSP, then we will take permission and we will take that lock from interlock from the wall set box. Then we will switch over to the PSP. So you can see here, we two PSPs, one is online and the other is. First we will start with opening this. Then only we can get the lock from inside that wall to open the other wall. No, so sorry to close the door. Okay, so one is open, then only we can close the other. At last, we'll safely keep the other. Okay. Okay, there are some other general guidelines for like securing wall positions. We'll see that one by one. Yeah, these are some examples. Walls on fire water distribution lines. It will be lock open or car seal open. Manual bypass isolation walls or PSVs or control walls. It will be lock closed or car. Upstream isolation of manual depressurization walls shall be also lock closed or car seal. Isolation walls on instruments which will initiate shutdown, that is ESD initiating instruments. It will be kept open condition, either by lock open or car seal open. Lock wall downstream of relief walls, as we saw, lock open. Isolation wall downstream of automatic blowdown, also lock open. Isolation walls from on-off controlled pumps, that is important, that also lock open. So pump recycle power, lock open. Maintenance main walls to fire, lock close. Okay. Now we will see some typical examples for pumps and compressors. First one is DBB arrangement for a pump. Second is normal SBB arrangement. Next is for compressors, also similar arrangement. Only changes that the blade here will be bent instead of bent. Next is a typical vessel. Also single block empty and double block empty. You can see here. For double block empty, the difference is that from all the bleed walls downstream, it will be taken to either drain or well. This also like changes from project to project, requirements, client requirements. Sometimes we don't provide the hard piping. Next is gas turbine engine. Any other fuel gas related equipment. It will be having an automatically operated TV arrangement with the automatic bleed wall for venting this. typical example is for a blowdown arrangement. So for this blowdown system, whether it is manual or automatic, can you see here two spec brakes? Right? Why it is required? Have any idea? Two spec brakes are there. You know, normally we provide one spec brake for pressure rating difference, right? After depressurizing, there will be a spec brake. Here we have two. Also, there's a 600 mm minimum. So after orifice, there will be pressure reduction as well as temperature reduction, right? So this spec brake is given for that. This is a typical example. The second one, that is the temperature difference spec brake, won't be required for all instances. You'll have to study that. If there is a reduction of like temperature below like minus 29, then we will have to go for LTCS. That's when the spec brake. Okay. And similarly for relief wards. Okay.
Okay, so the dense LTC's material it will be also only up to the isolation work.
No, here temperature spec brake. It will be here. That is downstream to LTCS. In case like temperature goes below the
So argument is the rating pressure.
rating pressure. Okay.
9%.
So here we have like spared relief order action for higher rating than 300 plus. Below 300 and above 600. Here we can see at inlet we have provided DB. Not in the other. Here for an unspaired relief order. Isolation is not required because there is spare vessel. There are some particular actions or controllers. You can see this for this will be the value. For 600 and above, we have to provide like TBB arrangement and control walls in parallel. For 300 and below, only one single flow can be required. For 600 and above, we require TBB arrangement, both inlet and outlet. In some cases, like for very open control walls, we can either avoid like huge bleed walls that will be like. So we are using your vessel drain arrangements and feeding arrangements. Okay. Now, we almost completed isolation philosophy. We can move on to the next, that is pairing philosophy. So why is pairing is required? As you can see, it is to have a sustained plant operation, reliability, ease of operation, and to avoid downtime during maintenance. If there is any capacity splitting required or teardown requirement, then also we use pairing. Which equipments require pairing? Some critical equipments which may cause a shutdown of the plant, it all requires pairing. And very critical instruments, as we discussed earlier, equipment which are having frequent maintenance or changeovers. If there is any regeneration required, like filters or dryers, it will also require spare. So critical equipments we run for a turn-down. There is no capacity splitting. We got that. Suppose our plant needs to be run at 30% turn down. then we'll have to take that into consideration while we're fixing the sparing. Now there are some general guidelines we'll see that. So for pumps, all the process pumps which whose failure will cause a shutdown of the unit needs to be spared. Okay. So if one pump is equal to meet the service duty, then one additional pump needs to be there as a spare. Same is the case for power generation. For power generation, if there is a failure of power supply envisaged for interruption-free operation, we will require sparing of the power generation system, whether it be EG or EG intake or diesel generator. N+1 is to prevent power damage. Similarly, for filters, as you saw, if there is a change of requirement, we require filters. For compressors also N+1 philosophies. For any static equipment, generally there is no spare considered like tanks or vessels. Next is for control valves. So spares are provided when failure of control valve will result in shutdown. Then safeguarding instruments is spares for more reliability, like 1 out of 2, 2 out of 3 voting we will provide for safeguarding instruments. Then BSVs. Equipment which do not have a spare will anyways be provided with 2 into 100 cases as a minimum. For equipment with spare, BSV won't be required because we can either take the equipment or change out. Spare will not be required for thermal plate ports. It also varies from time to time. In case of multiple PSVs, spare receivers of larger capacity and maximum set pressure available. I will see sparing how we solve this problem. Here, this is the equation. In operation mode, we'll have to equate this equation to 100%. So if we require 2 into 100 means one will be enough to make 100%. Then the other will be spare. Only 3 into 50%. So 2 working to make it 100, then the other will be spare. So 2 plus 1. 4 into 3, 33. That means 3 will be required to make it 100 and 1 will be spare. Similarly, as you see below. So I don't have to write it now. I'll share this after the presentation. Now we see vent and drain philosophy. Okay. Why do we require vent and drain philosophy? We have seen vent and drain being placed in all equipments and lines in a process pipe. So proper vent and drain design is very critical to ensure the safe and efficient operation of the plant. Inadequate venting and draining can lead to equipment damage, like the equipment can be burst or burst. And also product loss will be there, safety hazards will be there. So vents and drains can be further classified as process vents and drains. There is hydrostatic test vents and drains. We'll see what are these. Hydrostatic test vents and drains. So during a hydrostatic testing, you don't know what is hydrostatic testing, right? during the commissioning stage for structural integrity of the pipe. We do the hydrostatic test. So during that time, the equipment will be pressurized. Equipment or piping will be pressurized. So these are generally located at the highest point. The vents will be located at the highest point of the equipment to allow air escape when we are filling the test medium. Similarly, drains, hydrostatic test drains will be located at the lowest point so that we can drain out all the hydrostatic test medium after the test is done. See, it's a typical like an isometric view of piping arrangement. See the measures and all. Made an example. So can you tell where will we place the hydrostatic test vent and drain?
When did the most elevated?
8.59.
Okay. Okay, we'll see. Yeah. The drain will be at the lowest point and the vent will be
3.7.
at the top. Okay. Now we'll see what are the process vents and drains. Process vents and drains will be further classified based on the service functions and storage evacuation conditions. So based on service, it will be hazardous and non-hazardous. Based on function, it will be operational and non-operational. And the storage open and closed. Hazardous vents and drains. This will be routed to a closed drainage or maintain system. It might be separate for the fluid or a common one. Like example, LT pair, XT pair for the vent and drain will be closed. Right. Non-hazardous will be routed open atmosphere or open drain. Operational vent and drain. So when the equipment is in service, we require some venting or draining. For example, manual or auto drains of the vessels. If we are changing our vessel, there is some bottom drains left. We'll take that to a closed or open drain system. Similarly for venting also. There is operational vent and drain. Non-operational means when the equipment is taken for like shutdown or maintenance. That time the venting and draining is non-operation. Closed vent and drain. So it will be like intermittent hydrocarbon release during a maintenance time. It will be routed to the closed system, to the closed drain and flare system as an example. Similarly, open vent and drain. It will be like open venting, cold vent system, and open drain system. Now there are specific configurations for each equipments. We'll see one by one. For pumps, pumps will be having several drains. Like it will be manifolded together, like from the casing drain, from discharge and suction lines drain, be clubbed together. If more than one pump is there, each pump will be having separate manifold. So for centrifugal pump casing, will be having separate priming vent connection so that air can escape. We can see all these considerations later also. For heat exchanger also, vent and drain it will be avoided to the most extent. heat exchangers, vents and drains will not be there to the most extent. Usually only the hydro testing vents and drains will be provided on heat exchangers.
Central drain.
In some cases. That will not be operational. Okay. Even if it is there, that will be only for maintenance. That also we can club it together with the hydrostatic testing vents and drains. For vessels, there are many considerations to be considered. Like when may be connected to the overhead line, if the vapor line is on the top of the vessel. And maintenance during connection should be connected to the lowest point to allow complete drainage of the vessel. It won't be the maintenance drain won't be kept at the side of the vessel. We will have to remove all the content. Process drain will be placed below low level. So in terms of operation, like before low level is reached, it should not the air should not come through the process. Right? So it will be kept below the lower level. Okay, there are many other considerations. You can take that later also. For piping, there should be like non-pocket can be assessed for each lines. This is a major thing. Like high point vent and low point vent drain should be considered for the piping. And also the low pockets needs to be assessed for multi-phase pipe. Then slopes of vents and drain should also be like assessed, and for each project it should be assessed, and for which all lines it should be provided. Then we need to throw it in the PID. Then only the piping team will take it into consideration. Very nice. Next, some specific considerations for contour works. Okay, as we saw earlier, the fail close and fail low contour works. Here, it is liquid service drain. We saw in that earlier slide. I'll go back. In this arrangement, we can reduce the number of this bleed holes in some cases. In case of liquid service, if the valve is contour valve is fail close or low, then drain can be upstream or downstream. In vapor service, then should be upstream and downstream. It is a flashing liquid service. Vent and drain, both to be provided upstream and downstream. If it is a fail open, we only require one place. It will be mostly provided in the downstream of the contour. Okay. Next consideration is drain drum sizing. Drain vessel needs to be sized considering the largest credible drainage volume from the largest vessel from low level to the bottom. The drain drum should be capable of handling that. Then the contents which are drained to the drain drum will be either pumped out using a pump which will say route it back to the process or anywhere else. Then vacuum sucking also. Next philosophy is relief and blowdown. The water relief and blowdown philosophy. During an upset or emergency, the hydrocarbon liquid and gas needs to be evacuated safely to either save the close drain or the fly system. During a shutdown activity or maintenance, you'll have to anyways depressurize the whole system. It will be either the fluid will be either going to where or drain closed drain system. So how these reliefs are being done? It might be through relief wall, safety wall, EBDV, or even manual depressurize. If it is an equipment, you'll have to take it for shutdown. You'll have to manually depressurize the whole. Why do we require this below? Because it is a like we are relieving and blow down system. It is high pressure reliefs. It will be going to the coastline or fluid system. So safety also needs to be taken into consideration. So we'll have to follow all the standards and for proper design. Should be safe, less environmental impact should be there. Should not affect the process also. And it should be in line with the statutory requirements. In depth, I'm not going to this philosophy, leap and blow down. It itself is a huge topic. I suggest someone else try. Then there is safeguarding philosophy. Similarly, safeguarding philosophy is an important philosophy. In case of an emergency, say the plant is in upset condition, we need to ensure protection of personnel, assets, plant operation, and environment. That's why we require a safeguarding philosophy. This also I'm not covering in this topic. Then there is control philosophy. Control philosophy is like for a unit, there are some minimum required controls for properly proper functioning of that unit. That will be covered in control philosophy. That also as a separate topic. As an add-on, I'll go through the timing philosophy also. When do we refer timing philosophy? Suppose like there is a brownfield job. An existing plan is there, we need to tie it to the new plan. So we cannot do it like just by shutdowning the current plan. It is a like non-shutdown means you will have losses. So we need to plan the timing accordingly. So that's why we require a timing philosophy. Under that, we consider the types of time and the demolition and isolation of the existing plant. How it will be done? That will be formulating inside this time philosophy. So there also I am going through briefly only. Types are auto. There are tiles involving cutting and welding. There are cold doors also. That doesn't require any welding or cutting. Only sometimes the tile provision will be already provided. We have to just connect it. It will be isolated with a positive isolation gap. So we'll time this time. That's a cold door. Then there is hot tap. I think you all have a confusion with what is hot tap and cold door, right? This hot tap, there is no like some critical services are there. We will not be able to like shut down the process. Lively, we'll have to take a time. Then we opt for hot tapping. That is the line will be live. At the live time, we will be taking a time. We'll see how that is done. For example, yeah. Typical hot tapping example we can see. Here this line, it takes to be hot tap. So what are we going to do? We'll weld these like clamps like systems onto the line. You're only welding it on top of the line. You're not cutting it. This is called a line stop fitting. Line stop fitting. This is a line stopping machine. This- Here you can see the line is first closed, then only we are cutting it. It's isolated from the environment, then only we are cutting it. We close it. Yeah, this is the line stopping. Now, from the both sides, as we stop, then only we start auto. The water work is completed, we'll take out the line stop fitting. This valve is called family valve. Once the process is completed, the whole line stopping machine is removed. Okay, that's it. So anything else? Any questions?
പൊട്ടൊക്കെ കഴിഞ്ഞാലോ പ്ലാന്റ് അവിടെ തന്നെ ഉണ്ടാവും ആദ്യം
എടുക്കുന്നില്ലേ?
We can come to know there is a hot tapping done with that noise. That arrangement is some water that.
എനിക്ക് ആ വീഡിയോ ഫോട്ടോ ആപ്പിംഗ്
ചെറിയ ലാഗ് ഉണ്ട്. ഇതിൽ കാണുമ്പോൾ any questions? Percolating? Can we like
No questions.
Yeah.
No, I said no questions.
Okay. Okay. Thank you.
Thank you.